Hello everyone, welcome to my channel. Now in the last test video I have given one list of the reactions which are very important for the ISC 2024 examination and again for the CBSE again. And the other boards like the state boards can also follow, those are in the English medium. Okay, so today I will be discussing about the Aldol condensation reaction. Okay, these reactions are very important. Aldol condensation reaction. Now few things we have to learn from here, that which compounds will participate in this reaction and what type of the compounds will be. Now basically the Aldol condensation reactions are only done by the aldehyde and ketones. Okay, so only these aldehydes and ketone will participate in Aldol condensation reaction. Okay, now what type of aldehyde and ketone? The aldehyde and ketone which have the alpha hydrogen in them, they can participate in Aldol condensation reaction. Okay, so the first condition is that the compound should be aldehyde and ketone. The next is that they should have alpha hydrogen. Okay, having alpha hydrogen. Now how many molecules will participate? The aldehyde and ketone may be same or different, like two aldehydes may be same aldehydes or maybe different aldehydes. So the aldehyde and ketones may be same or different. Now they must be two, like 2 moles of aldehyde and ketones. Okay, and what are the reagents that in presence of that this will react? That the reagent should be dilute alkali, like dilute sodium hydroxide you can use, or barium hydroxide you can use, or potassium carbonate, or sodium carbonate. So these are the reagents in which basically the normal Aldol condensation reactions are done. Okay, so these are the 4 facts we have to learn, that in Aldol condensation reaction there must be aldehyde and ketone, and that must be 2 moles of aldehyde and ketone, and they should have alpha hydrogen. Now let us see that which are alpha hydrogen, means which compound have the alpha hydrogen and what is the meaning of this alpha hydrogen. Okay, now let us take the example. We know that this is a carbonyl group. Okay, C double bond 2, and we know the nature of this carbonyl group, that this oxygen is more electronegative than this carbon. So this oxygen will pull the bonded pair of electrons toward itself, making the oxygen delta minus and this carbon delta plus. Okay, now these 2 hands that those are joined to this carbon, if these 2 hands are having at least 1 hydrogen, then the compound, the group you can say will be aldehyde, and if these 2 are only, like R is the alkyl group, then the compound will be ketone. This must be ketone. So this is the major difference, the structural difference between aldehyde and ketone. The aldehyde must have 1 hydrogen that attached to the carbonyl group, but for the ketones they should have the R group. Okay, let me see this is working or not. Okay, I've just opened the window so that there should be no echo in the room. Okay, so this is the thing. Now let us take one example of aldehyde. This is the one aldehyde I have taken. Okay, now this aldehyde is called acetaldehyde. This is the common name of this acetaldehyde. You can go for the IPAC nomenclature also. Okay, so now this is the carbonyl carbon. Now the directly attached carbon with the carbonyl carbon is called alpha carbon. This is alpha carbon. Which one? This one. This carbon is alpha carbon. Now if we see the structure of this carbon having 3 hydrogen. These all hydrogens are attached by single bond. That means this carbon is sp3 hybridized. The carbon which is directly attached to the carbonyl carbon is called alpha carbon, and the hydrogens which are attached by single bond, those are called alpha hydrogen. That means to have only we can say this is alpha hydrogen if the carbon is sp3 hybridized. Okay, so these are 3 are alpha hydrogens. Now the compound which has the alpha hydrogen like this, they can participate only in the Aldol condensation reaction. There must be 2 or 3 exceptional cases, but this should be the main criteria that the compound which bears the alpha hydrogen, that is called that will participate in Aldol condensation reaction. Okay, like acetaldehyde and other. Now if we say this compound, that benzene with C double bond OH, that means this compound is benzaldehyde. Now this benzaldehyde do not participate in Aldol condensation reaction. Why? Because you can see that though this is alpha carbon, but it bears the double bond. That means this is sp2 in nature. So as it is sp2, this will not participate in Aldol condensation reaction. Clear? This is the major concept. So we can take acetaldehyde, propanaldehyde, butanaldehyde like that. Okay, acetone also will participate. This is one of the aldehyde that can participate in aldol, but acetone can also participate. What is the structure of acetone? This is the structure: CH3, C double bond O CH3. This is acetone. This can participate. Why? Because we can see these carbons are attached to the hydrogen by single bond. That means this what? That means these carbons are sp3. This is also sp3, and this can participate in aldol. Okay, so let us go for the reaction. Now if two same aldehyde or ketone having alpha hydrogen, they are reacting, they are combining with each other in presence of dilute alkali or the given reagents what I have shown, that will be a self-condensed reaction, not the cross. Self-condensed reaction, self-condensation reaction. Okay, aldol. Now let us take this example. I am taking 2 acetaldehyde. Okay, as a reagent as dilute sodium hydroxide. Okay, now we will see the first how this reaction is carried out, like what is the mechanism. Then we will go for the actual technique, how we can write the result. Okay, now what is the mechanism in this? In the first step, the alkali which is there, the sodium hydroxide, you know that this will furnish, as it is a base, it will form OH minus ion. Now this OH minus ion is a nucleophile. Now what it does in the first step of the Aldol condensation reaction, it takes one of the proton from, that means the hydrogen, attacks one of the hydrogen, alpha hydrogen of any one of the aldehyde. Okay, so what it will do, suppose I am taking this acetaldehyde here. Now let us write this compound like this, so it will better understand. Now this, suppose this is the alpha hydrogen, this will be taken by this OH minus ion. This is called protonation. Okay, now protonation is done. Now what will form? Water will form. Now we have seen that in the reactions where the water is formed, those reactions are chemically feasible, like those are spontaneous, those can easily done. So what will form? As this OH minus has taken this hydrogen, this bond will come on this carbon and will form an enolate ion. and resonance stabilized enolate ion. This can be called as carbon ion also, because the carbon will having the negative charge. So here this will be CH2 minus C double bond O hydrogen. Now this enolate ion is resonatically stable one. Why? This can happen. Okay, so this intermediate is stable, the reaction must go on. We know that from the normal mechanism that the reaction in which the intermediate is stable, that must be a good reaction. So this enolate ion is stable one. Now in second step, this enolate ion will attack the carbonyl carbon of the other aldehyde. So this is the other one which is taken. Now let us see the second step. Okay, so this second step, CH2 minus C double bond OH. Okay, this will attack the carbonyl carbon of the second aldehyde, and this is also reversible reaction. This is delta plus, this is delta minus. We know that negative charge is always attracted towards the positive charge, so this will happen. Now what will happen? What will write? We'll write starting with this CH3 CO minus. Okay, then this hydroxyl is attached with this. Now this entire compound which is here, you can connect with this CH2 C double bond H. Okay, now this one can take one proton from the water, okay, to form this compound. What is the compound? CH3 CHOH CH2 C double bond H. Let me see the lower can be visible or not. Yes, it is visible. So this one. Now you can, why this reaction is called aldol? Because the result you can see, it has a CH group. Okay, that means L. It has a OH group. That means all, you can say. So this is the combination of L and all, so aldol. Okay, now this is the compound which is the aldol compound. Okay, now after heating, this aldol product can give a tautomerized product that can be a good one having the double bond. That means that will be alpha beta unsaturated aldehyde. It can be formed from here. Let me show that. So this aldol product can shift into a more stabilized aldol product. How? Like a tautomerism. After removing one water molecule from here, we can write this CH2 like this, CHH. This bond will shift here, will form this one, CH3 CH double bond CH bond C double bond H. This is called crotonaldehyde. Okay, crotonaldehyde. So this is the actual mechanism of the aldol condensation reaction, self aldol condensation reaction. Okay, now this product we can write easily by having a trick. Okay, let us see that trick. We have taken two aldehyde molecule, two acetaldehyde molecule, this one CH3 C double bond OH, and other one. Like the other one we can write this like this, CH2 C double bond OH. It is basically the CH3. Now what we will do, we will shift one hydrogen here. Now after shifting, we know that this will form OH. This will form OH. Now let us start with this CH3 C, as it will form OH. There must be a single bond because we know that OH cannot be in double bond. Hydrogen is attached with this. Now write the entire one except this hydrogen. See, we can easily write the product. Again, you can get back to that crotonaldehyde also, this one. Okay, This is the self-Aldol condensation reaction. Understood? Now this same reaction, similar reaction can be done in presence of barium hydroxide. Okay, now if we take the other, like we have taken here aldehyde, if we go for the ketone, like let us take this one, acetone, two acetone molecules. Okay, if we take this barium hydroxide here, this will form a condensed product first, the aldol one. What we'll do, we'll shift one hydrogen from here and we'll get this CH3 COH. This CH3 must be written here, then this entire CH2 C double bond O will be joined here. Then you can get that product also back. This one. Okay, now this should be heated using iodine you can use. Okay, so you will be getting this product. So this is the basic knowledge of the Aldol condensation reaction. In next video, I guess the video is too long now, so we'll be taking more examples in the next video. So these are the common things I have taken. We can go for the other reactions also, means more examples of Aldol condensation reaction. Okay, so in the next video we'll be taking two or more examples of the Aldol condensation reaction, and we'll be seeing the crossed aldol also, where we will be taking the some aldehyde and other ketone. Okay, so stay tuned for that, and do subscribe my channel and please do like. Thank you.